Alright, let's talk about a job that's literally at the top of the world. When you see a skyscraper stretching into the clouds, you have to wonder how they even build something that tall. You can't just bring in a bigger crane because where would that even come from? This is the skyscraper's paradox. To build something impossibly high, you need a crane that can grow right alongside it. This isn't magic. It's one of the dirtiest, toughest, and most brilliant jobs out there. It's a story of heavy metal, brute force, and some seriously clever engineering that allows these giants to pull themselves up by their own bootstraps. The whole process starts not by going up, but by digging down deep into the earth. Before a single piece of the crane's tower is put in place, workers have to create a massive foundation. This isn't just a simple patch of concrete. We're talking about a gigantic block of steel-reinforced concrete that can weigh over 400 tons. That's 800,000 pounds of solid rock anchoring this thing to the planet. Pouring this foundation is a job in itself, often done in one continuous, grueling operation, to make sure it's a single, unbreakable mass. This base has to be perfect, because it's going to fight against the crane's own weight and the incredible force of high-altitude winds. Once that concrete anchor is cured and solid, it's time to bring in the first pieces of the puzzle. A smaller mobile crane, the kind you see driving on highways, is brought to the site. This crane does the initial heavy lifting. It carefully picks up the first few sections of the crane's main tower, or mast, and stacks them on top of the foundation. These steel lattice sections are bolted together with huge, high-tensile steel bolts, each one tightened to an incredible torque. This initial tower might only be about 50 to 100 feet tall, which seems small, but it's as high as the mobile crane can safely reach. From this point on, the tower crane is on its own. The mobile crane has done its part, and will soon leave the site. The partially built tower crane now sits there, a steel skeleton waiting to perform its most amazing trick. It has reached the limit of what outside help can provide. To get any taller, to reach the dizzying heights required to build a modern skyscraper, it has to rely on its own power. It has to build itself, piece by painstaking piece, climbing higher into the sky with each new section it adds. The real work, the dirty work, is just about to begin. So how does a crane lift itself? It uses a remarkable piece of equipment called a climbing frame, or a climbing cassette. This is a massive steel cage that wraps around the main mast, sitting just below the crane's rotating top part, the slewing unit, where the operator's cab and the long jib are located. This climbing frame is the heart of the self-assembly process. It's a heavy-duty hydraulic system designed for one purpose, to push the entire top of the crane upwards. It's a gritty, powerful, and methodical system that allows the crane to perform an incredible feat of self-levitation, one section at a time. The process, often called jumping, is a carefully choreographed sequence of events. First, the crane's own hook is used to lift a brand new mast section from the ground. This new section, typically about 20 feet long, is hoisted all the way up and positioned on a platform at the base of the climbing frame. Now, everything is in place for the climb. The operator, sitting hundreds of feet in the air, coordinates with the ground crew to ensure the new piece is ready. It's a moment of truth, where man and machine work in perfect sync to achieve the impossible. Next comes the incredible part. Powerful hydraulic rams inside the climbing frame begin to push against the existing mast. With immense force, these rams lift the entire upper assembly of the crane. We're talking about the operator's cab, the long horizontal jib, the counterweights, and the slewing unit, a combined weight of over 150 tons. The whole top of the crane slowly rises about 20 feet, creating a gap in the tower, right where the climbing frame is. It's a slow, deliberate, and nerve-wracking process that requires absolute precision and trust in the machinery. With the top of the crane held up by the hydraulics, the new mast section is slid into the newly created empty space within the climbing frame. Workers then secure it with massive steel pins and bolts, locking it firmly into the rest of the tower. Once the new section is safely integrated, the hydraulic rams retract, gently lowering the crane's upper assembly to rest on the newly installed piece. Just like that, the crane is now 20 feet taller. This entire dirty, greasy, and brilliant process is repeated over and over as the skyscraper rises from the ground. Now, you might be thinking that a super tall, skinny steel tower can't possibly be stable on its own, and you'd be absolutely right. A freestanding tower crane is only stable up to a certain height, usually around 200 to 300 feet. Beyond that, the forces of wind and the weight of the loads it lifts would be too much for it to handle. It would sway dangerously and could even collapse. To climb higher and continue its work, the crane needs a helping hand. It needs to become one with the very building it is creating, forming a symbiotic relationship to stay upright and strong. This is where tie-ins come into play. A tie-in is a heavy-duty steel support frame that physically connects the crane's mast to the building's structure. These aren't just simple ropes or wires, they are robust engineering marvels in their own right. The process involves bolting a massive horizontal steel collar around the crane's mast. From this collar, strong steel struts extend outwards and are anchored directly to the building's reinforced concrete floor slabs. These connections are incredibly strong, designed to transfer the immense lateral loads from the crane to the building itself. These tie-ins are installed periodically as the crane climbs higher. Typically, a new set of tie-ins is added every 10 to 20 floors. This ensures that the crane is never freestanding for more than a few hundred feet of its height. By anchoring the crane to the building's skeleton, the two structures essentially become a single, unified system. The building provides the stability the crane needs to resist powerful wind gusts and the immense torque generated by lifting heavy materials. In return, the crane provides the muscle needed to continue building the skyscraper higher and higher into the sky. Without these tie-ins, building our modern city skylines would be impossible. They are the unsung heroes of skyscraper construction, a critical job that ensures the safety and stability of these towering machines. Each connection is a testament to careful planning and brute force engineering, transforming the crane from a wobbly tower into a rock-solid workhorse. It's a dirty, high-stakes job of bolting steel to concrete, hundreds of feet above the ground, but it's what allows these giants to stand tall against the sky and get the job done. Every job has to come to an end, and for a tower crane, the end of the job means it has to come down. But how do you take apart a machine that built itself to be taller than the building it just finished? You can't bring in a bigger crane, so once again the crane has to rely on a bit of clever, reverse engineering. The process is often compared to a set of Russian nesting dolls, where smaller and smaller tools are used to dismantle the larger ones. It begins with the main crane starting to take itself apart, piece by piece. The main crane starts by lowering its own mast sections to the ground. Using the same climbing frame but in reverse, it removes a section, lowers it, and then descends onto the now shorter tower. This process is repeated until the crane is as short as it can possibly be while still sitting on the roof of the completed skyscraper. It has done its job, and now it's time for a smaller helper to come in and finish the dismantling process. This is where the job gets even more interesting, requiring a whole new crew and a different kind of crane. To remove the last parts of the main crane, a smaller recovery crane, often called a derrick, is brought to the roof. The components of this derrick are designed to be small enough to fit inside the building's freight elevator. A crew brings the pieces up and assembles the small crane by hand, right there on the rooftop. This newly built derrick then carefully dismantles the remaining parts of the main tower crane, the cab, the turntable, the jib, and the final mast sections, and lowers them all the way down to the ground below for removal. But the story doesn't end there. Now you have a smaller crane sitting on the roof, so an even smaller derrick is brought up in the elevator to dismantle the first recovery crane. This process might be repeated one more time until the final pieces are so small and light that a crew can disassemble them by hand. They carry these last components down in the freight elevator, leaving the roof completely clear. It's a dirty, complicated, and brilliant process that shows just how much thought goes into every single aspect of these incredible jobs.